All right, this is going to be part one of the XFOIL assignment. For this first part, we're just going to be comparing three different airfoils, comparing their angle of attack to the lift coefficient, drag coefficient, and your lift coefficient to drag coefficient ratio to the angle of attack. So first and foremost, I have completed most of this project already. I'm just going to go through the video just to show the steps I did take to do this. So as you can see here, we are in XFOIL. First, I'm going to load up the first airfoil, which is NACA 0015, symmetric airfoil. We have panel nodes of 160, which is sufficient enough to get our data from. Next, we're going to just type in our opper. Right now we are at inviscid flow, so we need to change that to viscous with V. And Reynolds number is going to be 3 to the 6, right there. And then, again, I already have this data recorded, but if you wanted to, you would type in PACC, and it would prompt you to create a file name, and then whenever you run your simulations, that's where your file name would be saved. So again, I already did this, so I will show you the file momentarily, but in order to get the proper, what we're looking for is we need to do a sequence of different angle of attacks. So we're going to go from -5 to 15, and with one increment in between. Click enter, and as you can see here, we get our values. And I'll minimize this really quickly. And I will minimize this as well, and I will go to XFOIL data. This is part 1 and data part 1. And this is just a mashup of all the data that I have collected from the different files. So after converting, actually, let me quickly show you let me minimize this, and I'll minimize that, and I will show the data where it actually would be written to. So when you do that PACC command, you can actually write all your files into these DAT files. So for mine, it was NACA 0015, so I'll open that up into Word. And this is what you get basically. In order to convert these to an Excel document, you can just hold the Alt button and highlight individual components and individual parts of the column, and then you can just copy and paste that into the Excel document. And I'll very quickly show the Excel document one more time. Minimize. Right here. So this is the data I have. So really quickly, I'll show you this is the NACA 0015. Off to the right here, we have our CL over CD ratios. We have our maximum there, and then we have a maximum there as well, or minimum. And then over to the right, you see the graphs comparing them. So this is below NACA 415 or 2415, same thing. Earlier, I was debating whether to choose Clark Y 11.7% smooth airfoil or the regular Clark Y. After figuring out how to properly put the coordinate files in the proper order, I was able to use Clark Y regular. And these are the results from that. But really quickly, again, I'm going to show you the NACA 2415 and how I actually got those results. So I'm going to go back into XFOIL. I'm going to click enter, and we're going to do NACA 2415. Actually, let me quit this really quick and reopen it just so we can see it a little bit more clearer there. Let me see if I'm sharing the correct screen. Okay, yes, I am. All right, so what we're going to do is we're going to do NACA and then 2415. It'll load it. If we want to see what it looks like, we can type in PPAR, and this is what our airfoil is going to look like. We'll minimize that screen, and then what we're going to do is we're not going to change anything, so we'll just click enter. Next, we're going to go to our opper again. We're going to change it to viscous flow. We're going to change it to 3 million Reynolds number. And again, if you were going to write a file here, which I already did, you would type in PACC and change your file name, and it would save to your XFOIL folder. For now, though, I'm just going to type in the sequence of angle of attacks from -5 to 15 and 1 degree of increment. Let that load up. It'll take a second, and it converged. Now, for some reason, it's not showing up on here, but again, the data, it did converge, and I'm going to show the data is in this PowerPoint here. And just to show you, we'll look at an angle of attack of 15 degrees right here, and our lift coefficient is 1.67-ish. So we look here, lift coefficient 1.476. So yeah, let me just double check that. 1.476. Yep, so this data does match. So the data I have here, again, it's extrapolated from this part right here in, where is this here? Not this one. It is from here, and I did NACA 2415. Again, you open it in Word, the same process as before. You just get it, copy and paste your values into Word, and then you can check them. Now for the last portion of part one, you have to actually download something off the internet. So for me, I used this UIUC airfoil data site. I clicked on the Clark Y airfoil, right, which one is it? It is this one here. So you can click that into the general airfoil shape there. And that's the one we're using. So I'm gonna go back here. Once you change your coordinates around, which I can actually show right here, Clarky right here. This is how your coordinates should look. The top coordinates here should actually be inverted. So you need to go into Word and invert them basically, and then you can save them and then they'll be usable. Exit there. Then I will go to here and we're gonna actually quit this really quick. Quit. We will reload this back up. So we're gonna load clarky.dat. It loads it. If we want to see it, we can type in PPAR and change our nodes. But because I like the nodes, we'll keep them. Actually, there's 122. I can actually adjust that. If we type in pane, it'll change it to 160. So next we're going to type in, I believe, exec. No, exec does not save it. So we're going to go to opper. We're going to change it to viscous, 3e to the 6. And again, same thing, the PACC, you could save it. So we're going to do a sequence of angles of attacks from -5 to 15 degrees with 1 increment. And as you can see here, we get our results converge, and they will be saved to the file that you saved it as. Let's see, moving on, I'll show you the graphs now. So again, this is all the data. All I did was basically plot angle of attack versus the lift coefficient for the 3 different airfoils, the angle of attack versus the drag coefficient, and then the angle of attack versus the CL to CD ratio. And all my results will be shown in my actual report. So that concludes the first portion of the part one of this assignment, and stay tuned for part 2. Thank you for watching.